Okay, we're working on page 4 on Module 7, Lesson 5. We had just finished G, found the Y-intercept, excuse me, to be 0, 1, and the rise over run to be 4 over 1. We plotted the point, rows 4 ran 1, rows 4 ran 1. I think everybody got that before the video stopped. Now we're switching to fractional slope, which it's no different than whole number slope because we make whole numbers into fractions too, right? So our y-intercept for this one, y-intercept always has x0 and 5 is the y-intercept. Sorry you can see words through this. I use recycled paper when I'm copying my stuff and it kind of shows through. Sorry about that. Okay, and M, my slope, is rise over run. And the reason I always write it is because one of the things students do wrong on the test is they run first and then rise. So I always write it just so it's just hopefully instilled in your brain. And it's always alphabetical order, so that's how you can remember if you're questioning yourself. So my y-intercept is 0, 5, and from that point I'm going to rise 1, run 2, rise 1, run 2, rise 1, run 2. And remember, if I need to go backwards, because I did have a question about this on our last test, I just do the opposite. The opposite of rise 1, run 2 is go down 1 and back 2, down 1, back 2. So if you run out a graph on Alex, you can just reverse your pattern and do just the opposite. The opposite of rise is fall. The opposite of run forward, go back. So any of those points will count. But I always like to put at least one doing it the right way so that when I put my other points in, I can make sure they're correct. So I always like to do 1, rise 1, run 2. And then if I want to go backwards, fine. But that way I know what the 2 points are that should line up. So fractional slope, no different. The only thing is we don't have to put it under 1 like we do the whole numbers. But everything else is the same. Okay, let's go ahead and go over to page 5. So on 5, we're just going to do J. So go ahead and try it on your own. And then I'll catch up to you as soon as I get my pages together. So the reason I skipped I is because it's just like the one we just did. But remember, if you want to do that one, the answer key is right there. So you can do any ones we skipped and check them. Page 6. Okay, so this is our last one. So this one is different from the previous one because we have a negative slope, but everything else is the same. So first we do our y-intercept, which is 0, 4. Then we do our slope, which is rise over run. And then we have to remember what we learned back in Module 5. The negative goes with the top number, so it's really -1 over +2. And like I said, anytime it's negative, I always put that positive down there to remind me to run forward so I don't trip, because a lot of students will go down 1 and then back 2. But it's not a double negative, it's one negative in the problem, and we choose to put it with the 1. So 0, 4, y-intercept, and this says go down 1, run forward 2, so you don't trip. Down 1, run forward 2, down 1, run forward 2. You can do as many of those as you like. And connect, arrows on both ends, and we are good to go. So that was our brief little review of graphing from Module 6. Okay, so the next page is the answer key, so we can do away with that. So our second thing we're going to review are the special cases, and then we're going to move on to writing the equations. So the special cases, as I think you all know, hopefully, and this is page 7. We're going to do all of them on this page. So the special cases are when there's only one variable. So they're very easy to recognize because all the other ones have an X and a Y. The special cases only have one variable. So if it's X equals, it goes through only the X-axis. That makes it a vertical line. One second, I forgot my paper in between for graphing. There we go. So X equals means it only passes through the X-axis. If it only passes through the X-axis, that makes it vertical. And we know vertical lines, there is no skiing. So that's an undefined slope. When it's Y equals, that means it only passes through the Y-axis. Remember, YX. And if it only passes through the Y-axis, then it is a horizontal line. And horizontal lines, oh, we can ski on them, but they're zero fun. Slope 0. So these are on the final. There's one of each of them. So probably good ones too. They're on your Module 7 test too, but they're also on the final. Actually, all 6 of these are on your Module 7 test and on your final, so just good to highlight all of them. So we have, write the equation. So remember that means it has an equal sign of a horizontal line. So in my head, I draw the axis, not in my head, actually. I draw the axes and I go, if it's a horizontal line, then it only goes through the Y-axis. So I know, since this is a special case, it only has one letter, and remember, it's named by which axis it passes through. So this one passes through only the Y, so I write Y equals, and then I go over to my point and go, what does Y equal? Oh, Y is 3. That's it. You don't have to do any Y equals mx plus b. You don't have to do any Y minus y1. When it's a special case, you should be able to go right to your problem. And I always draw the picture every time. Why? Because then I don't ever get it wrong and accidentally write x equals. So horizontal lines only pass through the y-axis. So they're Y equals, and we pull the Y coordinate from the point. I'll have people on the final write Y equals 1, and I'm like, really? That is not your Y coordinate. So make sure you pull your Y coordinate. Next, we have a vertical line. So vertical lines only pass through the x-axis. So I know right away it's x equals, because they're named by which axis they pass through. And I go to the point and go, oh, x is 1. That's it. That's all the work it takes to write an equation for one of our special cases, horizontal or vertical. Okay, so next we have number 3, undefined slope. Well, undefined I know means vertical because there's no skiing on vertical lines. So that tells me this. So no skiing on a vertical line, and vertical lines only go through the x. So I know this is x equals, and I pull the x coordinate from the point. Remember, x is first, y is second. And last, we have slope of 0. So I know 0 fun is a horizontal line. I think this marker is ready to go too. I have a new pack, but I just really want to use these up first. Such a miser. So horizontal line only goes through the y-axis. So we know it's y equals, and we pull the y coordinate down, it's 11. So those are exactly how I worded them on the final. I said there's a slope, write the equation, or write the equation of vertical line, or write the equation of horizontal line. And then I also have you graph both of them. So let's look at these graphs. So y equals 5 means it only goes through the y-axis. And it goes through at 5, so I can put my first dot. And remember, Alex wants more dots. It doesn't want just one. So since we know it's horizontal, because it only goes through the y-axis, because there's only a y, I could just pick random points. Pick this one and pick that one. And just click on those in Alex, and then you have your points. I mean, in real life, you don't have to do any points. You can just draw the horizontal line, but you have to play the game with the computer. So, and then last, x equals -4 means it goes only through the x-axis. Any line that only passes through the x-axis is vertical. So if it goes through the x-axis only, and then I could pick 2 other random points on either side, and there it is. So only go through the x. It should never touch the y-axis if it doesn't have a y in it. The only exception being x equals 0, then it lies on top of the y. But all other vertical lines do not touch the y-axis, and that's why they don't have a y in them. I'll have some students put the point there and then draw right on top, and I'm thinking, well, that doesn't just go through the y-axis or x-axis, that goes through the x and y. So make sure your line only passes through the x-axis at -4. Okay, so next we're going on to writing equations of lines, and I know you guys are probably bored out of your wits with this because we did it for what? How many pages do we have in that last lesson? Like 17 or 18 or some crazy number. But this is just a brief review and then we're done with it. But it's such an important concept. There will not be a math class where you don't need to know how to write the equation of a line. Sometimes given the slope and y-intercept. Sometimes given the slope and a random point. Sometimes given 2 points. So you need to know all the different scenarios. So we're putting them all together, doing the practice. Again, I'm skipping around. And if you look on page 9, there's the answer key. So any ones I don't do, if you want to do them, all you have to do is look on page 9 for the answer key. Okay, so when we're given the slope and the y-intercept, well, that's perfect because we have slope-intercept form, which m, remember, is the slope, and 0b is the y-intercept. And remember, in order to be the y-intercept, the x has to be 0. So let's look down this list. Are these all y-intercepts? Yes, 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 yes. So every single point on this page has x0. That means all the points given are y-intercepts. Are y-intercepts, or remember, sometimes we call them vertical intercepts. Same thing. So all the points on this page, because you'll see, starting on the next page, that's not true. Look at these points are not y-intercepts, not y-intercepts, not y-intercepts. So if x is not 0, it's not a y-intercept. So all the points given on this page are y-intercepts, and maybe above it we can write that means x is 0 on every point. So when they give us a y-intercept, we love it because guess what? There's no work because we have y equals mx plus b. And because we have y equals mx plus b,